Welcome back, fellow programmers, computer scientists. We are back once again. It is day 75 of daily LeetCode. As you can see, my hairline is still experiencing its Majin Vegeta character arc, but we are here nonetheless today to begin another session. We have a legendary comment from Thomas Wong himself, fast and slow pointer for the win. We must go slow to go fast, brother. Legendary comment. I put system design in the title yesterday. I'm going to be honest, it was a bit of a red herring. It had nothing to do with system design, but we had to test. You had to do some A/B testing, right? As per Netflix's engineering technical blog. So I wanted to see if it would work. Not necessarily an A/B test per se, but we had to try it. It did not produce many results, but it was pretty cool. Yeah, I think we've been reading the Netflix engineering blog, hopefully trying to extract some insights about system design, but it turns out that there's not, I think we read most of the infrastructure articles, so there's actually not much left, or as I couldn't find any remaining articles that I guess could understand. So either we have to level up and then return, so that might be what we'll have to go for. But as we mentioned yesterday, we're going to be leveling up heart health next. So make sure you get outside, make sure you have, or not even outside, make sure, you try and do some push-ups no matter who you are, what you look like, not even for any aesthetic needs, but just to get heart health, right? So we're leveling up heart health next as per one of the Copy Ninja's requirements. So yeah, I mean, if you're interested in any of that stuff, that is also in the Discord that you're going to want to join. Reflections on yesterday. Oh no, like I was saying about the engineering blogs, we read Netflix. I think we've extracted all the insight we have from Netflix. I tried to sign up for Quaster, which, if you don't know, is a email service that's going to send you emails about tech blogs and summaries about the posts. We haven't gotten any emails, so I don't really know what's going on there. Maybe I'm banned. I'm not exactly sure why I would be banned, but we're not exactly receiving any emails, so we have to look into that. Reflections. It is day 75, so it is a momentous day, mostly because it's day 75, so pretty hype. I've been promising a video that I would make when we reach 60 days, which would be like X things I learned from 60 days of LeetCode. We still haven't made that video. I've been meaning to get the setup and everything set up. I still haven't done it. So we're going to need to figure all that out. So there's just a lot that needs to be done, but a lot is in the motion. So that being the case, we're still on our grind for Ruby. And actually, I have one more thing to mention. I listened to a pretty cool video today by a channel called Gravemind. And yeah, it was just really interesting. It was pretty motivational, pretty much some anime interspliced with some pretty thought-provoking text. But we're back. Either way, we were able, from this video I watched, I heard one of the most legendary quotes. I try to keep a list of quotes that I think are pretty cool. This one is just legendary. I'm not even sure who said it, but it was in the video. But it goes, "I slept and dreamt that life was joy. I woke and saw that life was duty. I acted and behold, duty was joy." I think that's just a legendary phrase by a legendary auteur and a legendary human being, but I really don't know who said it. But either way, I think what the quote is really trying to get at is, I guess, maybe the beauty or maybe the hidden or bittersweet nature of work. And I guess maybe the surrounding or the soup, right? You're making a soup, right? It's hard to make the soup, but ultimately the act of making the soup is joy in and of itself, right? So to some degree, I think the quote is trying to get at the idea that duty, joy, responsibility, all of these things are somehow linked. And personally, I might be biased, but I definitely am in that bucket. I do think, to some respect, most of the time that I am working on something as hard as I can, or striving for something that in all aspects I'm generally relatively certain that I will never achieve, there is something beautiful about that, at least to me. And I think around day 25, I think I said something along the lines of that I would have liked my life to have somehow been an ode to work ethic. So hopefully, right? Hopefully we get to something like that. That'd be pretty cool, right? In the future, if I could make a video called Day 10,000, right? And hopefully, how many days would that be in the future? Day 10,000? I mean, 365 days. Let's just round that up to 400 days, right? 4,000 days would be 10 years. 8,000 days would be 20 years. So 25 years from now, I'd be 50. So hopefully at day 50, oh my God, at day 10,000, we will actually be a problematic programmer. That would be a sight to see. It'd be pretty cool to look back and see that most LeetCode problems are now futile. So yeah, you're gonna want to check back in 10,000 days. Me, Thomas Wong, Karina Rodriguez, Eric Adolph, For Boney, right? I'm just that guy, the copy ninja, Shubham, all who joined into Discord. Around day 10,000, we're going to be problematic, and we're going to be able to code a GPT-6 instance on the spot. So you're going to want to definitely be in the Discord for that day. It's going to be a very specific pizza party, right? For everyone, 10,000, or I guess, yeah, about 9,925 days from now, you're going to want to be invited to this pizza party. So make sure to join the Discord for that. And yeah, it was a cool quote. I'm going to put the link to the video in the description, as well as in the Discord. So you're going to have to join the Discord if you want to see the video. But yeah, work ethic is pretty cool. And so additionally, I also think I promised Thomas in the Discord that we would try previous week's contest, because he mentioned that it was pretty easy, which to me meant that it was time to swoop in and give it our best shot. So we're going to try last week's LeetCode contest. We have 45 minutes. The goal would be to just be able to solve one. So if we can solve actually just one of the problems, I will generally be delighted. Yeah, so if we could solve that, that would be pretty cool, not going to lie. So the contest is still up 308. We're going for here, you can do all link. Longest subsequence. Let me see if I can find it. I didn't know you could just click the contest button, so we've located it. It'll be weekly contest 308. It's the one that just ended. And we can do the virtual contest. So it'll be interesting to see if we can even solve one of these problems. I will be genuinely very pleased, but hopefully they're all easies, right? But our boy Thomas fried it. Apparently people are flying it in approximately 6 to 10 minutes, at least the top players. So we'll try our best. That being the case, you're going to want to join the Hyperbolic Coding Chamber Discord. This Discord is rapidly growing. And like I said, you're going to want to be invited to this pizza party 9,925 days from now. So you're going to want to set a reminder right now so you don't miss it. It's going to be right now at 10:18 p.m. Eastern Time. So make sure to join the Hyperbolic Coding Coalition for that notification. That being said, we're going to jump into the problem as usual. So 45 minutes. We'll see how far we get. We haven't done new problems in a little bit. So let's just jump into it. And yeah. Virtual contest. Ooh, I don't like how the screen is set up. I can't do it like this. I need to be able to see the problem and the code at the same time. You are given an integer array nums of length n and an integer array queries of length m. So we have two arrays, nums of length n and queries of length m. Return an array answer of length m, so number of queries, where answer sub I is the maximum size of a subsequence that you can take from nums such that the sum of its elements is less than or equal to query sub I. A subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. So let's map this problem statement to our example. We have an array nums 4, 5, 2, 1, right? An integer array. Oh, I forgot to make my screen small. Integer array nums of length m and an integer array queries of length m. Right? So we have nums and queries. Return an array answer of length m, which is the same length as queries, where answer sub I is the maximum size of a subsequence. You can take some from nums such that the sum of its elements is less than or equal to queries sub I. So given output sub 1, what is the maximum sum of elements that we can create that is less than or equal to 3? Right? And that answer is 2. So it's actually not sliding window, it's subsequence. So then we have 10, right? The largest subsequence we can make that's less than or equal to 10 is 3. Oh, it's the maximum size of the subsequence, not the actual number. So the greatest number that we can make that is less than or equal to 3 is 2 elements wide. So I'm wondering if we could do this. I'm wondering if we could do this in a specific fashion, right? If we copy these numbers here, right? We have nums equal this array, right? And we have this line commented out. We're going to do this in Ruby, by the way. Let me see if I'm not blocking all the code. We're not, so we're good. What if we sorted our input array, right? Because we don't necessarily care about the indexes here. What if we sorted our input array such that we got 1, 2, 4, 5, or we don't have a 3. We have 1, 2, 4, and 5, right? We have to produce some output array, right? And we know that our answer is going to be 2, 3, and 4, right? So what if we rephrase this problem, right, such that I think this algorithm might be n squared time. What our goal would be, right, is given a number 3, we'll assume that the largest window we can create is this entire window, right? So we'd have 1, 2, 4, 5, right? Our sum would be of length. Actually, what if we, if we sorted it, and what if we did a different approach? We'll just add numbers, right? They want the subsequence though. This gives me the vibes of another problem. Subsequence. So the first one I was gonna try, right, was that you'd have 1, 2, 4, and 5. Right, and this problem reminds me of contiguous, max contiguous subarray. Except that was for a contiguous subsequence. Maybe we could modify that algorithm to, that was for contiguous subarrays. Maybe we could modify this for contiguous subsequences. And I think we could do that. What if, right, we sorted the array and then we just iterated through, right? And what we would do is we would say, we'd have a counter, right? We just call it C. and we'll set C equal to the first element, or just 0, whatever. So 1, right? Set to 1 for now, right? And then we'll iterate to the next element, and we'll say, okay, if we add 2, right, plus our current sum, which is 1, is it greater than or equal to 3? Well, it is equal to 3, so we'll add it, right? So now we'll have C equals 3, right? And our window size, or subsequence size, is equal to 2, right? But now, since our array is sorted, we can pretty much just stop, right? So let's see if this works for 10, right? So we'll start C at 1 again, and our subsequences of size. Actually, we'll just start at 0, right? And we'll say, okay, is 1 less than or equal to 10? It is, so we'll add 1, and our subsequences of size 1. Then we'll go to 2, and we'll say, okay, if we add 2 to 1, is it less than or equal to 10? It's still less than or equal to 10, so we'll change it to 3. Our subsequent size is now 2. Then we're going to add 4, right? Is 4 less than, is the number we add, right, 3 plus 4 less than or equal to 10? It is, so we'll change it to 7. Subsequences size is now 3, right? And then we get to 5. We're going to say, is 7 plus 5 greater than or equal to 10? It's greater than, so we're going to skip it, and the max we can do is 3. Can we generate an example which breaks this code? What if we had a negative number? What if we had a negative number in the middle? Right, generally, we want a number that sums up to some of its elements is less than the sum is less than or equal. So in fact, if we had a negative 1, we'd still want to add it. But it actually still works, right? Except our maximum subsequence would actually be 4. And I think the great thing here, right, is that since we've sorted the array and we're looking for subsequence size, I think that this could work, right? So I hope we validated this enough. The way we're going to go about it is we're going to iterate over, or we're going to do queries times nums, or m times n operations, right? We'll just, I can't delete white space. Iterate over queries, right? Then we say iterate over nums. Then we can say if cur sum plus num greater, or if cur sum plus num is less than or equal to queries sub I, or we'll just say query add to cur sum, and then we'll just say increment subsequence size at the outer end of the loop, while we'll push subsequence size to output, reset subsequent. We don't have to reset it since it's going to be set at the top, and then we can just return output. Now, would this work with all the cases, just so we don't waste any time? We have 2, right? Over queries. Do any of these numbers, right? We'll say is 2 greater than or equal. Is cur sum, which is 0, plus 2 less than or equal to 1? No. So we pretty much would just push on 0. And we should be good with negative numbers. And we're sorting our input. So we're looking at n log n plus n times n, unfortunately. So we'll start with nums dot sort, and I think this should sort it in ascending order, and we'll just run it to start. Runtime error. Oh yeah, output doesn't exist. So our output is sorted. I just wanted to know that that does actually make sense. So now we're going to iterate over queries, right? We can say queries.each do query. Something seems wrong about this loop, but we're going to say queries.each do query. We're just going to say puts query. Something just feels off about this, but it should work. Okay, it works. We're just overthinking it. Right, then we want to iterate over nums. So we're going to say nums.each do num. Right, and then we're going to say if cur sum plus num is less than query. So when we start, we're going to need a new value, right? Cur sum, which is equal to 0, as well as subsequence, which is also equal to 0. And we're going to say if cur sum plus num is less than or equal to query. Yeah. Say if cur sum plus num is less than or equal to query, we're going to do cur sum plus equal num. And then we're going to do subsequence plus equal 1. And then out here, right, we still have to end. Wait, one of our loops, oh no, one of our loops. Yeah, out here, we're going to want to do output.push subsequence. This unexpected end of input on line 59. Oh yeah, we need an end. It works for the first case. All right, let's see if it works. I know it works for these other two cases. Use example test cases. Oh, it works. Well, we'll take it, right? Oh, it's an easy. Oh man, my confidence is blown up, man. This algorithm would take q times n time, or m by n time. I don't know if there's a better version of that. I'm sure there's a version you can do in n plus n time, but we don't have that solution. So we're going to go back to contest. No wonder these guys fried it in 6 minutes. These guys are a problem. So we have 30 minutes remaining. You're given a string S which contains stars star. In one operation, you can choose a star in S, remove the closest non-star character to its left, as well as remove the star itself. Return the string after all stars have been removed. Note the input will be generated such that the operation is always possible. It can be shown that the resulting string will always be unique. So we're given a string, leet, and code. And they want us to remove. You can choose a star in S. You can remove the closest non-star character to its left, as well as remove the star itself. So we remove this, then remove these two, and then we remove D and E. What you end up with is LeetCode. Performing the intervals from left to right. Closest character to the first star is T. S becomes LeetCode. Closest character to the second star is LeetCode. So we have star, we end up with an empty string. So to start, I'm thinking of two versions. I'm thinking of a version that works with a linked list and a map, and I'm thinking of a version that's going to work with a stack. So let's try the stack version first. Stack version first. And then we can try an LL plus map version, right? So let's think about this. We have LeetCode. What if we iterated through the string linearly and we push every non-star character onto the stack, right? We'd have Leet, then we find a star, we would pop the top of the stack, we'd have Lee. We'd find another star, pop the top of the stack, we'd have Lee. Then we'd push COD, we'd find a star, and we'd pop D off, and then we'd have LeetCode. Here we have erase, and then we find a star, we pop, we pop, we pop, and we pop. I think this does seem to map to the state of the string to some degree, and it does pass the first two cases. Can we generate a case where it doesn't work? What if we had a string where S equals LE? What if we had a string where we had L star, all right, E star, T star, right? We'd have L, we'd pop it, E star, pop both, E star, pop both, T star, pop both. So maybe that does work. And then do S dot each do car, right? And then we'll do end, and then we'll do stack. We'll say if car equals star, we'll do stack dot pop, else we'll do stack dot push car, and then we'll do end. I don't really like this small window on the side. So now we have this stack. Can you just do string equals stack dot join space puts string, and then we'll return string. Okay, so you can't do each on a string. I think you can do, I think I don't remember how it goes. It's like S or car in S do. For counter in. So let's try for counter in. For car in S do. That doesn't work either. Undefined method each. Wait, I don't have an each. Undefined method each for LeetCode string. Wait, I didn't have an each in here. Maybe it's, I'm just gonna return nil to start. On the line 23. Maybe you can't do, let's just do 1 or I in S dot length. What's the other one? For counter in 1 to 5 dot each do. So let's just do that. Do I, and then we'll say car is equal to S sub I. So we have 1 to 5 dot each do. And we definitely want S dot length. each do counter. 1 to 5 dot each dot do counter. So they're saying, oh, we want this to be 0. That's my bad. Okay, now we're just gonna uncomment both of these and then return string. And I don't actually know if there's a join method. I hope there is though. So our answer seems to work on the first case. Let's see if it works for, if we use example test cases. So if you submit it, how do you even know if it works? I guess you can't know that it works. Oh, I guess it works. It says submission. What does that mean? Except means your program has all test cases, or doesn't mean the algorithm is optimal. We'll take it. We'll take it. We'll take it. Minimum. Oh man, this sounds like DP. DP in the problem description is long. You're given a 0 indexed array of strings garbage. Where garbage. You're given a 0 indexed array of strings garbage, where garbage sub I represents the assortment of garbage at the ith house. Garbage I consists of only the characters M, P, and G, representing 1 unit of metal, paper, and glass garbage, respectively. Picking up 1 unit of any type of garbage takes 1 minute. You're also given a 0 indexed integer array travel. Travel sub I is the number of minutes needed to go from house I to house I plus 1. There are 3 garbage trucks in the city, each responsible for picking up 1 type of garbage. Each garbage truck starts at house 0 and must visit each house in order. However, they do not need to visit every house. Only 1 garbage truck may be used at any given moment. While 1 truck is driving or picking up garbage, the other 2 trucks cannot do anything. Return the minimum number of minutes needed to pick up all the garbage. Okay, let's map this to our example. We're given a 0 indexed array of strings garbage, where garbage sub I represents the assortment of garbage at the ith house. So garbage has G, P, GP, GG. It only consists of the characters M, P, or G. So it looks like at max we can have 1 unit at every location. You're also given a 0 indexed array travel, where travel sub I is the number of minutes to go from house I to house I plus 1. So if we're going from G to P, it takes 2, P to GP is 4, GP to GG is 3. 3 garbage trucks in the city, each responsible for picking up 1 type of garbage. Each garbage truck starts at house 0, must visit each house in order. However, they do not need to visit every house. So paper garbage truck travels from house 0 to house 1, collects the paper garbage at house 1. So we have 3 total minutes. Travels from house 1 to house 2, collects the paper garbage at house 2. Oh, okay. Travels from 0 to house 1. That's 2 minutes. Collects the paper garbage at house 1, which is 1 minute. Travels from house 1 to house 2, which is 4 minutes. So we have 7 total minutes so far. Collects the paper garbage at house 2. Altogether, it takes 8 minutes to pick up all the paper garbage. The glass garbage, that doesn't make sense. How does it take 8 minutes? Travels from 0 to 1, right? Picking up 1 unit of any type of garbage takes 1 minute. So we travel from 0 to 1, that's 2 minutes. Collect paper garbage at house 1, that's 1 minute, so 3 total minutes. Then we travel from 1 to 2, which is 4 minutes. So now we're at 7 minutes. Okay, and then we pick up the paper garbage at house 2, which is 8 minutes. Glass garbage truck collects the glass garbage at house 0. So 1 minute, travels from house 0 to house 1, travels from house 1 to house 2. So we have 7 total minutes, collects the glass garbage at house 2, which is 8 minutes, travels from house 2 to 3, which is 11 minutes, and then collects the glass garbage at house 2, which is 1, which is 13. Since there's no metal garbage, we not to consider the metal garbage truck. Metal garbage truck. I think there's some nuance here. The metal garbage truck takes 7 minutes to pick up all the metal garbage. So we started house 0. We have 3 total minutes spent here. Then we go to house 2. To do that, it takes 3, so we're at 6. And then we pick up 1 piece of metal. Makes sense. Paper garbage truck takes 15 minutes to take up all the paper garbage. We start at garbage 0, pick up no garbage. Then we travel to house 1. It took 3 minutes. We pick up 1 piece, that's 4. Then we add 10, that's 14. It should be 15. Yeah, 15 minutes to pick up all the paper garbage. 15 minutes to pick up all the glass garbage. Something doesn't seem right about this. Garbage length is it's always at least 2 elements. Only consists of letters M, P, and G. Looks like we can pick up multiple garbages at a particular index. Your travel.length is equal to garbage length length minus 1, which makes sense. Travel length is at least size 1, right? If garbage length is at minimum of size 2. So what if we just took a simple approach, right? What if we iterated through garbage? Right? What if we literally just create the system? We'll have 3 sums, right? G, P, and M, right? And then for the string, we're going to iterate over all the characters in the string. If we have G, right, we'll add 1 to G, 1 to M, 1 to P, so on. Then as we travel from I to I plus 1, we'll add travel time, iterate over the string. Right? And then for GP, we would do the same thing. And then the same thing for GG. And then we'll have a Boolean flag, right? What we'll call found garbage, or we can just have an array of Boolean flags, right? Where the 0, it's going to be 3 indexes based on 0, G, or M, P, and G for miles per gallon, just because it's easier to remember. And if we never found a singular piece of garbage for it, right, then we're going to set its sum to 0. That way, N, or our time complexity would be O of S, where S is the sum of the characters in the string. But that seems a little too simple. Something seems a little too simple about that. G is equal to 0. We'll have P is equal to 0 to start, right? And we want to iterate over travel. Something seems too simple about that, but it works for the two cases. I can't think of a case where it doesn't work. But there's a part in the problem where it says only one garbage truck may be used at any given moment. Or one truck is driving or picking up the garbage. Oh, so trucks can't pick up garbage at the same time. And I think that's what's not shown in the problem here. That's what's not shown in the problem here. So we'll just do it based on the system, right, that we've seen. We'll just do an array over M, P, and G. We'll say each do item, right? And now we're going to iterate over MPG, and then for each type of item, right, we can say garbage dot each do bag. We'll just call it a bag of garbage, right? And then we'll do end, and then we'll say type, and then for here we'll say bag dot or 0 dot bag dot length dot do, right? We want to iterate over the string, right? And we'll just call it I, and we'll say end, and then we'll say item is actually equal to bag sub I, and here we'll just put item, and then we'll turn nil to start. But I just want to see if this makes sense. So we have G, P, GP, GG, and we have this 3 times. So that makes sense. Right, and at the top, we're gonna have a value called found garbage equals false, right? And after we iterate over all the garbage, right, we're gonna say, and let's just say we have a hash, right, where M is equal to 0, P is equal to 0, and G is equal to 0. Right, what we're going to say is hash sub, and we want these all actually to be capital and strings. I guess the goal with this, right, is to have some way to keep track of the values or the garbage we pick up or the total time elapsed, right? But in the case where hash sub item, right, we're going to want to say if we never found garbage, right, then we're going to want to say hash sub type equals or actually we don't actually have to do hash sub type. We can just keep, I guess we can just keep a value called total time, which is equal to 0. And then we won't actually need this garbage array. Yeah, now we duplicate a lot of nonsense. So if not found garbage, right, we're just going to say some or we'll have a value called time elapsed, right, which is going to be equal to 0, right? And if we found garbage, we'll do sum plus equal time elapsed. That way we can actually just return sum. That way we don't need this total time, but we do need sum equals 0, or we can just call it total time for variable transparency. And this shouldn't work, but I'm just gonna run it to make sure that syntax makes sense. Unexpected end. And I always forget we need an end after the while, after the if. Right, and sum does not exist. So this doesn't work yet, right? We have item is equal to bag sub I, right? And what we want to say, right, is if item equals type, and we want to do total time plus equal 1, right? Because we found a unit, right, for that item type. Oh, I see why the problem is difficult. You don't, right, after we do GP and GP, we don't actually want to keep visiting P, right? And that's the difference. So, as and I think we could fix this, right? Instead of doing garbage.each, I think what they said is you don't have to visit all the houses. Each garbage truck start, you must visit each house in order, but you don't have to visit every house. So we just need basically the last index to stop in. So we can change this to 0. Right, going until, right, last index sub type dot each do bag, right? And then basically to find the last index for each type, this is getting a little convoluted. We'll copy this one here. We'll have MP and G, right? And we'll call it last index, which will be a hash of M going to 0, right? G going to 0 for P, right? Going to 0, and then G going to 0. Then we'll iterate over MP and G, right? And the goal is just to find the last index. Right? And so I think, right, for each type, can we find the last index of each type in one go? I think we can, actually. I actually think we can. So we'll say garbage.each.do bag. We have 5 minutes for each item of garbage, right? We can say, we can just loop over the string, right? And we'll say 0 dot 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 bag length, so iterate over each. We'll say each dot do, well, this is the string, bag dot length. So now we have each index, and we can just say if bag sub I, right, equals M, right, if bag sub I equals M, right, then we're just going to say M or last index sub M. We actually want the last index of the bag. Oh man, this is getting messy. We change this to bag index, right? And we'll say bag is equal to garbage sub bag index. Right, and then last index will be equal to bag index, and then we just need two more of these. We change M to P, M to G, and then we'll put last index So the problem that, you definitely want garbage.length here. So 0 last index type, right? We're missing a period. Undefined method length on bag. Right, there's no length here because it's just right, so this is getting a little convoluted. We'll have index, right, and item index. Maybe this is more understandable if we say car index. Or if bag sub car index, right, total time. And then here is actually index, and I think, right, of the last index, I think we do want bag.length. We just want bag to actually exist, and bag is going to be equal to garbage sub bag index. So our answer is 3, and that's definitely not the correct answer. So our last M is 0, right? And then for P, our last index is 2, and then it's G, right? GP, 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 GP. And for MP and G, oh, right. If found garbage, item equals type, right? We'll say found garbage equals true. Or now it's changed, right? We don't actually have to say that we found garbage to stop. Because now we have the final index where we know total time, and then we still have to add the time from travel. All things considered, does this make sense? There's 1 unit of paper, 1 unit of this. We ran out of time, but it should be, in total we should be getting 5. So if you pick up G, I see what's happening. I'm saying total time plus equals 1. We should be doing time elapsed plus equals 1. Iterate over the last index, right? 0 at the last to bag index. We get the bag for the bag index, and then we literally iterate over the bag. Then for the item, we check if the item is equal. We have triple equals here. I actually don't even know what that means in Ruby. G, right? So if we're working on paper next, right, we should only do pretty much, we're gonna go to G, right? P, GP, G, P, GP. All right, and so our last index for G we'll say puts what last index for type is so we do G P 0 1. Oh, so I guess we definitely want to go right, including the last index. Last index for M is 0. We can also start all these values at -1. Oh, right. And then we do this part right here for last index, right? If last index of type not equal -1, then we'll do end. So you have G, right? So we, if item equals type, I should be reading the code like for the output. We have GP, GP. So we have GP, GP, right? We have two papers, right? So I think what we should get out here is let's time elapsed might be a better indicator of what's going on. And then for 3, right? Yeah, that doesn't make sense. That's what I'm saying. We didn't even make sure it makes sense. Ugh. 0, 1, 2, 3, 4, right? So presumably if we add the travel time, right, 2, 4, and 3, and then what we'll do, we'll just say if last index, no, we'll say if bag index or if travel sub bag index plus 1 does not equal nil, I'm going to say time elapsed plus equal travel sub bag index. One, and then we'll do end. So you have 9, right? Traveling from 0 to 1 should give us 2, right? 1 to 2 should give us 4, which is 6, right? And then 6 plus 1 and 2. All right, so traveling from these 3 should give us a sum of 6. Actually, no, going from G to P, right, we had 2. Going from P to GP, we had 4, so it's 6, right? And then for paper, right, we had 1 and 1, we should get 7, but we're somehow getting 9. Or I think we don't want to add bag index plus 1. We just want to add bag index, I think. This is closer to the correct answer, I think, so we're missing the last travel to 21. Okay, that was not the right change. Okay, I'm just making changes. We're basically missing the last 3 you get from going from GP to GG. Here, our last index would be 0, 1, 2, and our last index for G is 3. So somehow we're ending up with 18. Right, and if bag index plus 1 is not equal nil, so that's a bit strange. When you're going from G to P, you get 2. Going from P to G, you get 4. And then from going, because you're going from 0. I see, I think this is happening too many times. This is happening per character. We want this to happen per bag. So I'm surprised I was even getting the correct answer the first time. And then I think if we change last index to visit, no wait, I don't think, yeah, that's the wrong one, I think. So our last index isn't being considered, but 0, we are considering the last index itself. The last index is 4. We should have got it though. Going from 0 to 1, we had 2. 1 to 2, we had 4. 1 to 3, we had 3. I mean, 2 to 3. I'm just gonna print, I'm gonna put bag index. Zero on. It's unclear what is going on. Bag index. Zero, 1, 2. Maybe we just have an else, special case, right, where else if, right, if bag index equals the last element, right, the last bag, we probably didn't consider the time it takes to get there, so we can do time elapsed plus equal travel. So bag index. So it's 21. Does it work for a harder test case. This is the real test. The goal outcome in this case is to be 37. We get 37. I'll remove the puts, but I'm generally skeptical. Oof. We have G, M, and P, right? Then we should visit the first one for 1, right? Then if we're going from G to M, right? At 1 and 1, it's going to be 2. We have 3 so far. And then for P, going from 0 to 1 is 1, right? 4, we should have 5. Wait. Oh, it expected 8. Oh, I see. So I have 1 too many. So if you go for G, what do we calculate for G? It looks like it's just going to be 1. For M, we're going to have a total of 5. So we have 6. Right, then you travel from G to M to P, should be 4 plus 1, be 4 plus 1, which would give you 5. Wait, traveling for G, right, you'd have 1, right? For G, you don't have to travel anywhere, we have 1. For M, you have to travel from 0 to 1, which is 1. Unit of time for this array plus 1 element, which is 2 plus 1 so far would be I think we're including 1 too many indexes, and I think it's because of this if travel bag subindex plus 1 does not equal null. So what if we said bag index, right? We don't want to add it, right, in the case where we're at last index, right? So if bag index does not equal last index, so type now we get the correct answer. Right, so I think we have the correct answer now. Our solution just takes far too long. Fortunately, I think we can cache it. If we're going to iterate over a bag, then I think we can say right, for a particular index, we can just keep track of how many bags per specific type are there. So what we could do, right, is we actually, maybe a simpler way to do it actually is just to do an array. Maybe we can just say array.new, right? And the number of elements it's going to have is actually going to be garbage.length. So I wonder if we can do that. It looks like you can do that, right? And our cache is just going to be an array of arrays, basically. And so we can just do garbage.each.do bag, and we're just going to do cache.push, right? And this time and space on this is not good. We're just going to push an empty array to start. And the goal is it's going to have an empty array of 3 values, basically. And then we'll just cache the values. So the first thing we want to do, right, we only want to do this part where we calculate the time elapsed for a bag, right? Or actually we want to set it to -1, which would mean we haven't saved anything for this string. And so we're basically going to say is if cache sub bag index equals -1, then we want to do the work here, right, for the time elapsed, at least for the amount that we would calculate for looking through each bag, right? After we're done, say and then instead of doing actually, I think I overcomplicated. What we really want to know is the number of M, P's, or G's for a particular index. So we actually just need an array. All right, which we technically pre-calculate. We just want to know the number of bags in a slot, basically. So if we wanted to do that, so we don't actually have to do anything special, but just And it wouldn't even just be cache, it would just be count. Which would store a hash for a particular index. For this index of characters, right, we could say bag.each do for 0, right? Bag.length.do each, right? And we'll just call it bag index right, and then we can just, we'll say if bag sub bag and this is not the bag index, this is the car index. So the car index, right, equals m. Then we're going to do and we'll set the value equal to 0. We're going to say hash sub m, right, plus, and it might actually just be simpler if we do m p g dot each do. Whew, this is spaghetti code. Item type and then we're going to say hash. We're going to say if bag sub car index equals item type. I'm going to say hash sub item type plus equal 1. At the end of it, we'll say count dot push hash, then puts count. Forgot an if on the end. Right, and then we had this if cache the bag index. What we're going to want to replace this entire loop with is time elapsed plus equals count sub type, or count sub bag index sub type. Do I still have the part where it starts? And then here, since we're just creating the array, so now we get 8. We've pre-counted everything. Let's see if our solution still works. Our answer is 20 and 35 respectively. Sub item type. So for G, right, we have a hash where the only thing is G and it's 1. The only thing is P, right? In the second index, in the third index, we have G and P equals 1. I'm actually confused as to what's being printed here. We iterate 0 going to garbage.length to I, then we can say count sub I equals hash. Something is definitely up here. Undefined local variable bag. Bag is going to be equal to garbage sub I. Okay, I'm generally confused as to why this is giving me so much trouble. We do garbage.each.do bag, take away bag sub I, and at the end, instead of doing count sub I, oh, I see, we have it in the wrong. We can do count.push hash. So is this the correct answer, 21? It is, so let's try and use the example test cases. We get 21 and 37. Seems to be what they're looking for. Delete puts.count. So this version still seems to be very, very, very slow. What if we didn't do 3? We're no longer doing any iterations. Or I guess since we're looking over the last index, all right, we might as well do that here. So what if we fuse this entire block? Right. I'm going to change this to P, to G, change this to M, and then at the end of this bag, right, we'll still do the usual puts dot count. So now we should be saving some time. Maybe 3 iterations over this massively long input array is ridiculous. But I would think that 3n wouldn't matter. Or maybe it's 3n times the number of characters, which I guess could be pretty bad. What's the constraints? At garbage, sub I.length is at max 10 characters, so it's like 3. I guess garbage length can be pretty long. Maybe it only accepts a linear time algorithm. What if we just took this m.gp part out? Wait a sec. Oh no, yeah. Move this down here, and then what if we literally just did garbage dot each dot do garbage or bag Wait a second. Oh, this is a mess. This is a mess. This is a mess. We'll just have to try this one tomorrow, but ultimately the result wasn't bad. We said 45 minutes, but we ended up spending an hour and a half, so here's what it is.